All right, today we're going to be subtracting mixed numbers. And we're just going to jump right into it. Just like adding mixed numbers, I like to stack them, even if the problem's given to me vertically, because then I have some room over here to make equivalent fractions and do some work if I need to convert and make it possible to subtract. Anyway, let's start with the fractional amounts, and I sort of imagine that there's a ones column. Think about it, maybe a fractional column. 2/3 take away 2/5. Well, immediately I see that the numbers don't match. So I think, okay, does 5 divided by another number get me 3? No, never. Would 3 times another factor get me 5? No. So that tells me right away that I'm going to have to make 2 new denominators. And since I know they can both 5 times 3 and 3 times 5 make 15, that's what I'm going to choose. How did I get there? 5 times what? 3 gets me 15. So I know I'm multiplying by 3 over 3, and I just continue that out in the numerator. 2 times 3 is 6. How did I get from 3 to 15? Times 5. So that gives me all the information I need to know about what to multiply the numerator by as well. So I have 10/15 take away 6/15. I don't really need that anymore. And again, a mathematician doesn't scribble it out, doesn't need to erase it, just a line through it helps me know I don't need that, because maybe I've made an error and I may need to go back and see what I did back there. But right now, it looks like we have smooth sailing. We can just take 10/15, take 6 away, and we're left with 4/15. Now I come to the whole number part. 3 wholes, take away 2 wholes, leaves me with 1 whole. The final answer is 1 4/15. So we had to make common denominators, and then it was smooth sailing from there. Let's go to this next one. 4 1/8. Take away 2 1/4. And maybe if I should lower this, it'd be better. All right, so I see right away I have a problem. The denominators don't match, but I'm looking like, 4 times 2 is 8. 8 divided by 2 is 4. So I've got some options here. I really only have to make one new denominator. So I think I'll just go ahead and make 1/4, convert it into a fraction that has eighths. So 4 times 2, that tells me 2 over 2. And 2 is there. So I don't need this anymore, but now I have eighths. So we're good. Smooth sailing. Almost, but not quite, because I have 1/8 take away 2/8. I don't have enough in the fractional column at least, but don't ever forget that this is all one number, 4 1/8. So I can borrow. 4 wholes become 3 wholes because I took one of these whole numbers and converted it into fraction form. Just like we take tens and convert them into ones, hundreds and convert them into tens when we're carrying them over. So we are taking this whole, but here's the question. What would this whole look like in fractional form? What fraction would represent a whole in the number 4 1/8? Well, I know that the denominator is going to be eighths. And I know if I have all 8 of them, that's a whole. So all I did was converted it to a fractional amount. And now I have not just 1/8, I have 1/8 plus 8/8. So altogether, the top amount is 9/8. So now it's smooth sailing. 9/8 take away 2/8 is 7/8. 3 wholes take away 2 wholes is 1 whole. So my final answer is 1 7/8. Let's do one that's on the work for today. Because even though the denominators may get big, it's still the same procedure. And we can work it out if we have the skill of making equivalent fractions and we know how to borrow and convert a whole number into its fraction form, right? And the denominator, as always, is going to be a big player in this whole process. So remember, there's your label telling you what unit we're working with in this number, 16 3/9. That's ninths of the unit. And 10 2/5. I can see the denominators don't match. I see that I can't just make a new denominator for one of them. I have to make 2 new fractions, making equivalents. I need an equivalent for 3/9 and an equivalent for 2/5. Well, I know that 9 times 5 is 45. So I can be pretty confident that that will be a number that will work. 5 times what gets me 45? 9. So 2 times 9 is 18. And up here, we've got 9 times what gets me 45, and that's 5. So that, just knowing that relationship from here to here, 9 times 5 is 45. That gives me the information I need to know what to multiply the numerator by. 3 times 5 is 15. So we've got our new fractions, and it's smooth sailing. We can just subtract now, right? No, we can't, because 15 45ths, take away 18 45ths. I just don't have enough 45ths at the moment. However, it's 16 and 15 45ths. This is all one number. So just converting one of these wholes into a fraction form is not going to change the entire value at the top amount. So 16 wholes become 15 wholes. Why? Because I took one of these wholes and I put it into a fractional form. And here's where you have to use your brain for, really think about it for a second. What would a whole fraction look like? Well, I have to ask myself, first of all, what's the denominator? 45ths. How many 45ths would I need to make the whole thing? 45 of them. And that's it. Now I have how many? I have 60 45ths. I added 15 45ths and 45 45ths. That's a mouthful, but I did end up with 60 45ths on the top. So my total number right here, if I read the whole thing, is 15 and 60 45ths. Now I can just go ahead and subtract my fractional amounts. 60 45ths, take away 18 45ths is going to be, let's do 60, take away 18. 6 becomes 5, 10, 2, 4, 42 45ths is what we have left. 42 45ths is our final answer in the fractional amount. And then 15 take away 10 is 5. So my final answer here is going to be 5 and 42 45ths. That's a mouthful. And we're going to be learning about making the simplest fractional amount possible. But even though that's big, it is correct. Even though we have lots of pieces and lots of those pieces, it still is an accurate answer. Let's go down to this last one I have for you. 7 and 2/12 plus 2 1/2. I see the denominators don't match, but no problem. By now, it's just second nature. I can easily convert 1/2 into a fraction that has 12ths instead of halves. I just have to give you more of them, right? 6. So 6, and that makes perfect sense, right? 6/12 is the same as 1/2. This is just a lot of littler pieces, more of the smaller parts, or fewer of a larger part. And this we would call a more simple form, but they are both equivalent fractions. So now we're ready to move on. 2/12 take away 6/12. Can't do it, but again, this is all one number, so I can borrow. 7 wholes become 6 wholes. Why? Because I took one of those wholes and I put it into fractional form. And here's where you have to think, okay, what would a whole fraction look like in this number, 6 and 2/12? Well, again, my denominator is my sort of my anchor. So I know I'm talking about 12ths because there it is. And 12/12 would be a whole. So I have my 2/12 I had to begin with, plus another 12/12, and you end up with 14/12. And then you can just smooth sailing. You can just go ahead and subtract 8/12, 16, 4 and 8/12. That is a terrible 2, sorry. Okay, so 4 and 8/12. And what we were talking about a little bit before was that, yes, this is an accurate answer, but is this fraction in its most simple form? And by simple form, we mean, is it have the fewest number of parts? Right now we have 12 parts making a whole. And I would divide, you'll always divide to make an equivalent fraction that is the simplest, meaning the fewer. So let's see if we can find a number that both 8 and 12 will divide by, that will create a fraction that has fewer pieces. So it's really just making an equivalent fraction with division and trying to make it the fewest number of pieces possible. So I immediately know that they have 4 in common. They share that factor. So I'm going to go ahead and divide by 4 and see what we get. 12 divided by 4 is 3. 8 divided by 4 is 2, 2/3. That is the simplest form of 8/12. So if I wanted to write my final answer to this subtraction problem in its simplest form, which is the most common, easiest to read, acceptable, everyone recognizes it, it would be 4 2/3. And I cannot make that any more simple. Right? That looks pretty straightforward, doesn't it? It's a lot more straightforward than some of the other numbered fractional amounts we've been working with. So subtracting, we've learned about borrowing in order to subtract the fractional amounts. And we've even talked about how to make an equivalent fraction that's actually the simplest form, and that's with division. So use all that, do your best on the work we have today, and I think you're going to do great.